In this video, I want to give you a short teaser for one of the later parts of the ILAP-X, DNS64 and NAT64. Before we look at what these actually do, let's start why we need these mechanisms. Imagine the following scenario. We have a client that is IPv6 only, which means it has no IPv4 address. At the top left here. It is quite common nowadays that, for example, your internet service provider gives you only an IPv6 address to use, but no dedicated IPv4 address. Now we also have an IPv4 only server somewhere in the internet, here at the bottom right. An example could be, for example, an older privately hosted server that was never upgraded to support IPv6. Both of them are somehow connected over the internet, involving multiple routers in between. However, as a user, we want to access the IPv4 only server. But as both hosts use different protocol versions, one IPv4, one IPv6, there is no way that these hosts directly communicate with each other. DNS64 and NAT64 offer a solution for that issue. Using the scenario from before, we look at how these mechanisms solve the incompatibility between these two protocol versions. First, DNS64 comes into play, which builds upon regular DNS. That means our IPv4 only server needs a domain name, which in this case is eb.ilapx. A regular DNS could map this domain name to the according IPv4 address, which we can also see above the domain name. Now, as mentioned, in our case, the client cannot do anything with an IPv4 address, as he is IPv6 only. This is where DNS64 can help. The client sends a regular DNS request for eb.ilapx to the DNS64. From the client's perspective, this looks like a regular DNS resolver or name server. However, what DNS64 actually does is generating an artificial IPv6 address for the IPv4 only server. This works pretty simple. The DNS64 just takes the 96-bit long IPv6 prefix, for example 64:ff9b/96, and combines it with the 32-bit IPv4 address of the server. In total, that gives us a 128-bit IPv6 address. Note that we used a mixed notation using both hexadecimal notation of IPv6 and the decimal notation of IPv4. We could also translate everything to hex, but in the end we just have 128-bit. This notation makes it easier to see how the address is constructed. As last step, this new address is returned to the client, who now thinks it has a regular IPv6 address of the IPv4 only server. Now the client can send IPv6 packets to the given address. However, the server can still only receive IPv4 packets. Therefore, we need a translation mechanism in between that can translate between IPv6 and IPv4. This is the job of NAT64. Based on the prefix used for the artificial IPv6 address, in our example 64:ff9b/96, routers in a network are configured to forward packets for such prefixes to a NAT64. The NAT64 then extracts the IPv4 address of the server from the received IPv6 address. Remember, these are just the last 32-bit. In addition, it translates the other information from the IPv6 header to the according IPv4 header. Then it sends the packet to the server using IPv4. As NAT64 uses its own IPv4 address as source, responses from the server go back to the NAT64. The NAT64 has a mapping stored between the received IPv4 address and the IPv6 client that initially sent the request and can translate the packet back to IPv6. Finally, it sends a response back to the client. This is a rather simple to understand but effective way to enable communication between IPv6 and IPv4 only hosts in the network, which we will talk about in more detail in our practical course ILAP-X, which will start soon on edX. The practical exercise for DNS64 and NAT64 looks as follows. In the core network emulator, we have on the left side some hosts that only support IPv6. We can verify that by opening a terminal and checking the assigned IP addresses using this command. As you can see, the client only has IPv6 addresses assigned to it. On the right side, outside of our internal network, we have an IPv4 only web server called EB. We can check that too. While we see an IPv6 address and an IPv4 address, the IPv6 address is link local and not usable for communication over multiple routers. Therefore, as a web server, EB is IPv4 only. During the hands-on, we will learn multiple things. Which hosts need to support IPv4, IPv6, or both? How to adapt a normal DNS server, which we can see here, in order to work as DNS64. How to set up NAT64 on a host to enable translation between the IPv6 addresses generated by the DNS64 and the IPv4 address of the actual target, in this case EB. And last but not least, how to configure the routers in our network correctly to forward packets with a DNS64 prefix to the NAT64. Afterwards, we have a fully functional DNS64 and NAT64 setup and can open a website on the IPv4 only EB server from one of our IPv6 only clients. Let's try that out quickly. Opening a Firefox on host 1, and now we can try whether we can contact eb.ilapx, which is the website that is hosted on the EB server. And it worked! Congratulations! We accessed this IPv4 only web server. And the best thing, the client doesn't even notice that this is happening. From its perspective, it just sends and receives normal IPv6 packets. If you got curious about how that exactly works with the configuration and so on, have a look at our massive open online course ILAP-X that will start soon.